I have said that it is mass upon volume. How much of mass of something is in a given area? How much of something is packed into something, right?
Sir,
Mhm.
sir, are we going to use these formulas in the exams or like in any
No,
kind of
no,
question
no,
from
no, no.
based
You are
on?
not going to have any question on this. No,
Okay, sir.
since since this term came up now, so I thought let's elaborate on it. So that is simply the density. How much
Okay,
of
okay.
something is packed into a given area? For example, I could be having two bags of something. In one bag, I have packed something very tightly. Okay, now I have, let's say I am having two bags. In one bag, I have packed 10 kilogram of rice. In another one, I kept only 8 kilogram of rice. So therefore, I would say that bag number A is more denser than that of bag number B because more material has been packed into it. So density in simple term is the how much of mass is packed into a given volume, as simple as that. And all these are the physical properties which we study in physics, right? That is what we study in physics. Science is having three branches: physics, chemistry, and biology. So that is what we study in physics. We study about the shape, size, volume, density, etc. But in chemistry, we study about the inner composition of the given substance. What is it actually made up of? Is it, for example, water? Water is made up of hydrogen and oxygen. Huh? For example, baking soda, right? It is made up of what? What is caustic soda made up of? What is washing powder made up of? Right now, what is candle made up of? What is carbon
Yes, sir.
dioxide is made up of? So this is what we study in chemistry. So if the inner composition of the material is changing, that we study in chemical, that is the chemical property of it. And if the chemical composition changes, so that is said to be a chemical change, right now. And for a chemical change, later on I will tell you, a reaction has to take place. For a chemical change to happen, a chemical reaction has to take place. For example, consider the example of photosynthesis. Different raw materials are reacting to form glucose and oxygen. So a chemical reaction has taken place between water, between carbon dioxide in the presence of sunlight, right now. So a chemical reaction has to happen there. Okay, no? But that is not necessarily true in the case of physical changes. Also, I did told you that whenever a physical or a chemical change happens, there is a change in the energy also. Hope you guys got this concept of the energy change, which I told you,
Yes, sir.
right now. Also understand this one more thing here. Like plants will be taking up the light energy from the sun, right now. So plants will be taking up the light energy from the sun to prepare their food. And their food will be taken up by the consumers, right? And is we humans, animals, these are the consumers. And when consumers will die, when the producers and the consumers both will die, so then they will be eaten by the decomposers, namely the bacteria, fungus, worms, flies, etc. And then later on, you know that when decomposition happens, when something is decomposing, heat is released. If you ever were to see like vermicomposting, vermicomposting, we studied a little bit about vermicomposting in the chapter wastewater treatment, a wastewater story. I did told about vermicomposting. So when vermicomposting is done using worms now, so in the process of breakdown of the biodegradable waste, they will be releasing heat. So see, from the sun, heat was being taken up by the plants, light was being taken up by the plants, and ultimately it returns back to the environment. Getting it or not? The energy here went into several changes, and ultimately it is written back in the form of heat into the environment. Is this clear or not? Let me tell you
Yes,
what
sir.
basically happened. From sun, heat and light was taken up, and that was taken up by the plants in order to prepare the food, that is glucose. So here basically light energy was changed into a chemical energy,
Yes, sir.
right? And when it was being taken up by weak consumers, and when the consumers die, they will be when the consumers will die, they will be decomposed, right? So when decomposition takes place, heat is released into the environment ultimately. So you can notice how the light energy has changed into chemical energy, and then again it has changed into the heat energy. So
Heat
energy,
energy.
heat energy, getting it now. So this is the cycle of change of energy in the nature. Hmm. So hope it is clear. So chemical change we studied, the chemical property of the substances are those characteristics of a substance that will be describing its nature. For example, why NaCl is different from HCl? Why is it so?
because it has different substances.
Correct. Also, NaCl is also white in color. Also, this is also white in color, right? No, both of them are white in color.
Yes, sir.
Okay, for example, you were to have, you guys understand this, right? Right? This thing. Or basically, let me write this thing. Rice flour. All these three are white in color, isn't it? And that is the physical
Yes, sir.
property of it. Salt is white. Okay, now wheat flour is right. Rice flour is also white in color. But why these are three different things? Because of their chemical
Chemical
composition,
properties.
right? Now, so basically, the chemical composition of the substances gives its nature. The nature of the given substance is because of its chemical composition. Getting it now? So that is the thing about it. So when there will be change in it, so that will be referred to as a chemical change. We had several examples like rusting of iron was there. When the magnesium ribbon was burned in the presence of air, that was also an example, right? The process how
Yes, sir.
medicines are formed, right? That also is a chemical change. How metals will be extracted from the ores. For example, you know that metals are not found in the pure form in the nature; they have to be extracted from the ores. You know the basic things. You studied this in geography as well. For example, aluminum has to be extracted from aluminum oxide. So this is bauxite, which is an ore from which aluminum metal is extracted. Right now, and you should also know that that in the Earth's crust, the metal which is found in abundant quantity, that is aluminum. Okay, no. So in Earth's crust, you will get to see that aluminum is found in maximum quantity. Silica is also found in maximum quantity. Getting it now? What I'm trying to say. So extraction of metals from their ores also is an example of a chemical change. Okay, so hope you guys are getting it. Also in the image, you can see that certain words are written over here. Like here, it is being talking about the chemical properties of the given substances. We know shape, size, volume, density. These are the physical attributes of a substance. What are the chemical attributes? Like for example, something you might not be able to understand right now, which you will be standing in class 9th and in class 11th. Some things you would be able to relate with here. For example, certain materials are very flammable. Like for example, sodium is a metal which is a very soft metal, right? You can literally cut it using a knife, and it is very explosive it is very explosive in nature. If sodium metals were to be dropped in water, it will basically explode, right? So thereby it has to be kept in kerosene to protect it from catching fire. Getting into what I'm saying?
So can you explain it again?
Huh. You have an example of a metal called as sodium. The symbol is Na. Okay, na Sundus, Vaiga and Chakrika. So this is a very explosive metal. Explosive meaning that
Yes,
when it comes in contact with water now, and when it comes in contact with basically moisture, it will start to catch fire. So thereby it has to be stored under kerosene. You have to store this in kerosene to avoid its contact with water. So this is the chemical property of the sodium, that it is flammable in nature, right? Getting it now. Then chemical stability. Chemical stability, what does it mean? For example, if you were to leave petrol in open, so you might see that if the level of petrol was this, after 24 hours, it might decrease to this. So petrol is petrol is volatile in nature. It is very volatile, meaning that it can evaporate at a faster rate as compared to water, right? Now, then you have seen like different materials, like it's not like all the materials will burn at the same temperature. Is it that a paper and a wood will catch fire at the same temperature? Yes.
Sure, sorry, what?
Will two substances catch fire on the same temperature? Combustion, you guys understand? Basically, the process of burning in the presence of oxygen, that is
sir, I
Yes,
didn't
combustion.
sir.
get the question.
My question was that you would see, for example, in order for petrol to catch fire or wood to catch fire, which one requires more amount of heat to catch fire, petrol or wood?
Sir,
Wood.
wood.
Wood requires, right? Take some more examples. Take example of like cow dung cakes are also used in rural villages, rural areas. Take some more example. You can have example of kerosene, kerosene, right? So there's a thing called as heat of combustion. Like in order for a given substance to catch fire, you have to heat it to a certain temperature. After that only it will catch fire. Getting it now? You can add coal in it also, right? So in order to uh, burn coal or kerosene or carbon cakes or the petrol or the wood, they will be requiring different amount of temperature to burn. So that is also a chemical property of the substance. Right now, right now we haven't started talking about the chemical changes. We're just not talking about chemical properties of the substances. Getting it now? An oxidation state that is not relatable to your class right now. Okay, no? Toxicity you can relate with this. Certain materials are very toxic in nature. Certain chemicals are toxic in nature. Okay, no?
Okay, sir.
Like for sulfur gas is toxic in nature. It can cause irritation in nose. It can cause problems in lungs. Right now, sulfur is also called as sulfur is also called as evil's gold, or this is term like this. I think sulfur is basically very precious. Okay, now sulfur is used in various purposes. Sulfur is used in the explosives. It is used in matchsticks also. So sulfur, the people who are extracting sulfur now, so they are basically extracting it from a mine, and the process is very dangerous for their health, because if they were to inhale smokes of sulfur, it causes problems in the respiratory tract. So all these are the chemical attributes of a given substances. There are some more which you don't have to study right now. What are these things? You will be studying that later on in higher classes. Is that clear? Now the
Yes,
next
Yes,
image
sir.
shows you the chemical changes here, where a reaction will be taking place here. Here a reaction is going to take place here. The earlier we have studied about, these are the chemical attributes of the substances, right? Now let's see. For example, burning of wood. So burning of wood, it releases heat, right now. So burning of different substances like wood or the candle, it will be producing heat. Okay, no? Also the a new substance will be formed, that is ash. And it is different from the products, from the reactants. Hence, it's a chemical change right now. So the wood that is now ash, both are different. Metabolism is basically refers to the different type of activities happening inside our body, like digestion, assimilation, absorption of food, right now, transport of bloods. These are all different kind of metabolic activities that goes inside our body. So in the image, you have different examples of chemical changes what that is happening there. Some common examples are there. Have a look at electroplating and chemical battery. So see, earlier also in the previous class I did told you, like when electricity passes through a conductor, it can produce different type of effects. It can produce magnetic effect and it can cause chemical effects also. So
Yes,
for
sir.
example, if you were to take a salt solution, take some salt, dissolve it in water, take a iron nail, take a iron nail and take a copper wire, take a copper wire and connect these two to a battery. Connect these two with a battery. Let's say you have connected it to a battery here. What you will see that after some time, copper will start depositing over the iron nail. All right, now copper will start depositing over the iron nail. So that there shows you an example. So that there shows you an example.
Like we have to put in which solution?
You can simply take a salt solution. Simply take some salt and add in water. Okay, now if you have a dilute acid, you can take dilute acid also. Dilute acid meaning weak acid. Okay, now you will be taking iron nail and copper wire, dip it into it, connect them with the two wires, and the two wires has to be connected to the terminals of the battery, opposite terminals of the battery. So that is also a chemical change here, right now. And this process where a metal is deposited over another metal, it is termed as electroplating. That is electricity plating is basically deposition of one metal over another. So the simple thing is that when a metal is deposited over another metal with the help of electricity, that is called as an electroplating. So this is also an example. Getting it or not?
Yes.
Then you have the batteries. For example, the batteries in inverter batteries. So
Yes, sir.
in that battery, you will see that due to the chemical reactions that are happening inside the battery, electric current is produced. Right now. So see there. So there also you will see that you will be having a similar structure as like a electroplating, but it's a little bit different from electroplating. So the thing is that due to chemical energy, electrical energy is produced inside in the inverter batteries. There also you might have noticed that after every 3 months or 6 months, you have to add water to it. You have to add water into it. Okay, now. So these are some of the chemical changes around us inside our body and around us also, which we observe on a day-to-day basis. Is that clear to everyone or not?
So
Yes,
can
you
you
guys.
repeat what again?
I just told you like these are the normal examples of chemical changes that are happening around us. Okay, no? Some changes are happening inside our body as well.
Yes,
So
sir.
the basic thing is that when new substances are formed, that is a chemical change.
Yes, sir.
So new substances are formed, either heat will be radiated or either heat will be absorbed. So that is also an indication of chemical change. If the sound is produced, if a sound is produced, that can also be an example of chemical change. If the
Yes.
color of the substance changes, yeah, you guys were saying something.
No, sir.
Or if a gas is evolved in the reaction, right now, if there is a formation of solid as a residue, as I gave you an example of this one, where you have deposited where you have left this rusty iron nail in an acid. So the waste will be deposited at the bottom. So these are the indication that a chemical reaction is happening, namely radiation or absorption of heat, production of sound can be there, change in color of the solution. You will notice that earlier, let's say if you were to take this acid, for example, let me show you so that one to you. See what we have done here. We have taken copper sulfate solution here. Copper sulfate solution we have taken here, which is blue in color, and you are adding iron into it. So thereby iron sulfate is formed, which is green in color, and copper will be deposited over the iron. This will be more clear if you were to look at this activity. So see what basically happened in this activity now. So you had taken you had taken an iron nail basically, right? You dipped that into copper sulfate solution. Okay. So copper sulfate solution, this copper sulfate solution, and you have dipped an iron nail into it. And copper is more reactive than iron. Copper is more reactive than iron. So what will happen? The copper will replace iron here. It will start to replace the surface iron of this iron nail, and it will start to deposit over the iron. And copper, it is actually talking only about copper, it is brown in color. Getting it now? And copper sulfate, the solution is actually bluish in color. This is bluish in color. So when you will be dipping an iron nail in the copper sulfate solution, copper starts depositing over the iron, and also the iron will be dissolving in the solution. So you will also notice the color of the solution has changed now. Look at the color. Is it the same as it was earlier?
No, sir.
Yes. No. Right now. So now
No,
it
sir.
has formed FeSO4. Getting it now? So that is the thing over here. So copper will be basically deposited. Let me write the reaction. CuSO4 plus Fe. Okay. So that copper will be deposited over it right now. And
Yes, sir.
iron will be left in the solution like this. Also, copper sulfate that we are talking over here, this is actually an acidic substance. Copper sulfate is a acidic substance. Getting it or not?
Yes, sir.
Hmm.
Sir, can I just go drink some water and come?
No issues. Okay, let's quickly try to cover this up, then we will be discussing some questions. So far, if you guys have any doubt, please do let me know. The first example is that of rusting. So we have already previously also we did talked about this. Just have a look at the reaction taking place here. Iron, water, and oxygen. This is the formula of rust. Is this a irreversible reaction or reversible reaction? That is an irreversible reaction, right? So how do we
The
prevent the...
chemistry to the last slide.
Huh. This is a chemical change, obviously, and it is irreversible in nature, right? So we have
Yeah, you can
example
move
of...
ahead.
Yes, Sundus, will you please repeat again?
I said you can move ahead, sir.
Yeah. How do we prevent rusting? By basically doing electroplating of iron. So see, there's a process called galvanization. So it is the process of depositing a layer of zinc on iron. How it is done? Recall this image. Moments ago, I did showed you this image here. This electroplating. Okay now, Vaika, Sundus and Chakrika. So with the help of this electroplating process, a layer of zinc is deposited over the iron in order to prevent it from rusting. Getting it or not? So this is
Yes, sir.
basically galvanization being done here. Also, you know that zinc is less reactive than iron. So iron will easily corrode when it comes in contact with moisture, but zinc will not easily corrode when it comes in contact with moisture. Hope you guys are able to understand this thing. So certain metals are
Yes.
very reactive, some are not that much reactive. So we have deposited a less reactive metal over a very reactive metal. Getting it, Chakrika?
Yes, sir.
Another way in order to protect iron from rusting is alloy or simply applying a paint over it. We have studied about these
Can
things
you go to the
also.
previous slide?
Haha, sure. You can have some
So you
other
can go ahead.
examples also. Apart from galvanization, guys, we know that like the cans. You see the
Sir,
cans.
oiling?
Oiling is also done, but oiling is basically done in those parts now where oiling is done to basically reduce the friction there, particularly to prevent it from rusting. We have galvanization. Cans, tin is plated over iron. Okay, no? So there is a coating of tin done over the iron in order to prevent it from rusting. So cans that you see, okay, no? Cold drink cans. We have other examples also. For example, if you were to look at the kitchen utensils, many kitchen utensils, um, taps, car handles, right now, so they appear very shiny, and uh, they do not catch scratches very easily. So we do coating of chromium also on iron. So if you want, you can remember these also. Like apart from doing a coating of zinc over iron, we do coating of tin and chromium also. Getting it or not? Okay, let's move ahead then. Some of the chemical changes in our everyday life are as follows. Respiration and photosynthesis. If in these two, if you guys have any question, please do let me know. Or
No,
else
sir.
I will be moving ahead. Understood this now?
Yes, sir.
Okay. Just give me the equation of respiration. Just explain this to me. Vaika, how respiration is a chemical change? Please elaborate on it. Yeah, how respiration is a um, chemical change. Anyone else?
So what were you saying? Can we just repeat it? I
Yeah.
was at the washroom.
No, sure. How is respiration a chemical change? Sundus, Chakrika, you guys?
So can I?
Uh-huh.
So respiration is a chemical change because um, basically we're taking in oxygen, which is already being used by our body,
To
and it
taken by
really,
our body. Mhm.
yeah, basically taken by our body, and carbon dioxide is basically released out. We can't basically reverse that process
Hmm.
So like
again.
it
So
releases energy.
It gives us energy. Correct. 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 So basically, what is being broken down here?
Glucose.
Glucose
glucose,
in
what?
presence of
Uh,
oxygen.
so then water.
Water is obviously for any metabolic activity to happen in our body, water is required. Okay, now. So energy is released here, right? And the products formed are as follows. You will be getting carbon dioxide and water, and energy is released. The energy that is released, it is stored in the form of some molecules, right? By the way, water is not utilized, but it is released here. Okay, now guys. So let me write the chemical formula C6H12O6 plus O2. It releases carbon dioxide and water, and it releases energy in the form of ATP. Do remember about ATP as well. And if we were to talk about how much calorie of energy is released here in this process right now, so in the process, the amount of energy that will be released, it is somewhere around 150,000 kilojoule. How much? 150 kilojoule. Getting it or not? Joule, I have told you, like joule is the unit of energy. It is the SI unit of energy.
Yes, sir.
So joule is there, and 1 kilojoule is 1000 joules. All right, no? So that means how many joules are there? 150,000 joules of energy are released. And this example that I have gave you, that is in the example, that is the example of animals actually. You know that respiration can happen in the body of yeast also. Yeast can also do respiration, isn't it? But they do anaerobic respiration. Remember that. Can you tell me that yeast does the anaerobic respiration where? Where does it does the anaerobic respiration?
Sir, when we are like baking something, like dough or
So
something.
also when we're making alcohol,
Alcohol. The process is called as fermentation,
fermentation.
Yes,
right?
sir.
Okay. Who developed the process of fermentation, by the way? Fermentation was developed by whom? It was Louis Pasteur. Okay, no? Louis Pasteur. And Louis Pasteur is the same person who developed the process of pasteurization also. Have you guys read about pasteurization yet or not? Sundus, Vaika, Chakrika.
So
You
I've
guys have
not
read
heard
about
of.
pasteurization? Not heard of it.
No, sir.
Yeah.
Okay, this thing you must have heard of. Heard about pasteurized milk. Heard of it now?
Sir, I'll be back in a minute.
Okay, no issues. Yeah, Chakrika, what about you? Have you heard of this?
So still no
Pasteurized milk.
idea.
Please repeat that. I didn't get it.
I said like still no idea.
No idea. Like in the market, there are milks, packet milks are there in the market, and some of them are labeled as pasteurized milk.
Sir,
So
I've
what are you
heard of
saying?
them, but I don't know like clearly.
Okay, let me just explain this.
Saying?
See, we were discussing about this same thing, Chakrika. See, like that food can get spoiled if they are not preserved. There are different methods in order to preserve the food, right? You might have seen like pickles. Pickle is basically preservation of certain kind of foods. Addition of salt can preserve the food. Addition of sugar can preserve the food. Addition of oil preserves the food, right? Now addition of some chemical preservatives preserves the food from spoiling it. So same, how do we preserve the milk from spoiling? So in large boilers, first of all, milk will be heated to a temperature of 70 degrees Celsius, right? And then it will be immediately cooled down for 50 to 30 seconds. At freezing point, it will be cooled down, right now. So pasteurization is the process to kill the bacteria in the milk. So when it is heated up to 70 degrees Celsius, most of the bacteria are killed in it. And then it is again for 15 to 30 seconds, it goes into deep freezing, right now. So that kills whatever remaining bacteria might be present in. But basically, germs we are talking about it. Germs here. Getting it or not? So that is the process of pasteurization. Is that clear? So we were actually talking about yeast. Yeast also does the process of respiration, right? So that can also be taken as an example. But will it be doing respiration in the presence of oxygen or absence?
The absent.
So can you repeat the
Absence.
question?
In anaerobic respiration that is being done by the yeast, is it aerobic or anaerobic? I mean to say, that is anaerobic, right?
Yes, sir,
Uh,
it is anaerobic.
do you guys recall what were the products formed in anaerobic respiration?
Oh,
We
yes,
will
sir.
Alcohol.
alcohol.
Alcohol, water, small amount of energy,
Yes, sir.
lactic acid.
Or heat.
Lactic acid is formed, right? Correct, correct. So in absence of air, it will be producing alcohol plus carbon dioxide plus energy is also released, but a small amount of energy is released, right? No, very small amount of energy is released. Anaerobic respiration, you know, that it can happen inside our body also, right? No, so thereby, if it were to happen in the muscles now, so thereby you get to see that lactic acid is formed, right? Now, so same thing is happening here. Only difference is that here lactic acid is formed, and with proper massage, right? Now if warm water were to be poured over that area or warm massage is done over that area, so thereby it will further break down into carbon dioxide and then
So they're also
H2O.
taking a hot water bath, right?
How we can take a hot water bath as well, right? Now so that will basically relieve the pain because lactic acid is not converted into carbon dioxide and H2O. Okay, lactic is the same acid which is found in the milk as well. Okay, now anyways, coming back to the process, so basically I was telling the process of fermentation and the process of pasteurization both were invented by the same scientist. The name is Louis Pasteur. Okay, now
Okay, sir.
anyways, let's come back to the topic. Okay, so these were some of the man-made chemical changes which we already know: combustion of fuels, cleaning of tiles, softening of hot water, so which we are not going to waste time over because we have studied that. Burning of magnesium is strip, so we studied about this also. Another thing I needed to discuss about in this one is that when magnesium burns in the presence of oxygen, it gives a very dazzling light, and the residue that is collected in this china dish is basically a bowl like structure that is used in the laboratories. So magnesium oxide is formed. So magnesium oxide, when you will be adding water to it, so another chemical reaction happens here, and you get magnesium hydroxide. This is also called as milk of magnesia.
Magnesium.
All right, now milk of magnesia. Now, what I basically wanted to say you here that if you were to test for the pH of milk of magnesia, when you were to look at the pH of it, will it be above 7 or less than 7? Hmm,
So above 7.
above 7, because it's a basic substance, right? Now,
Yes,
Yes, sir.
sir.
so do remember that thing also. Now, the reaction between copper sulfate and the iron. Moments ago, I was talking about it as well. So you have got a iron blade here. So you have dipped it in copper sulfate solution, right? So first of all, how to prepare the solution? Just mix a teaspoon of copper sulfate. It comes in the form of powder. You can purchase if it is available in the market. Normally, it is not there. So mix a teaspoon of copper sulfate in about half cup of water. Add few drops of sulfuric acid to the mixture. So you have added sulfuric acid. Sulfuric acid, that is H2SO4, right? So once you do that, now you'll be obtaining a blue colored solution. Okay. Now keep a small sample of the solution in a test tube or a small glass bottle. So which we are going to see over here. Basically, what reaction is going to happen? Moments ago, we have studied the same thing. So once you would be putting a nail in this now, when we studied, once we put the nail in it, what basically happened? The copper started to deposit over the iron nail, right now. So that is also an example. So let me just conclude what are the different things you will be observing here. First thing is that earlier I noted down that the color of the solution is blue. When I added iron into it, now the solution changed to green. Why is it so? Because this reaction took place here. This reaction happened here. Copper sulfate reacted with iron to form iron sulfate, and copper was deposited over the iron. Copper sulfate reacted with iron. Fe means iron. Okay. So iron now displaced copper to react with sulfate. So thereby iron sulfate is formed. Okay, now this is iron sulfate, and thereby copper is also formed. Copper is basically depositing over this iron. You guys getting it or not? So you know that iron sulfate is actually green in color and this is blue in color. So two changes we can observe here. New products are formed and the color of the solution also changes, isn't it? See, earlier this is the color, this was the color. Now the color has changed to greenish because from copper sulfate now it has changed to iron sulfate. And notice the color of the blade, it has also turned brown because copper has deposited over the iron blade here. Is that clear to everyone or not?
Yes, sir.
Chakrika, you got it? Sundus,
Yes, sir.
right now? So that is the thing over here. Now we have example of reaction between acetic acid and baking soda also. Acetic acid, that is vinegar. So you have taken some vinegar and baking soda, you will add them. And normally when you will be adding them, no, bubbles will start to form in it. Okay, no? So those bubbles are actually carbon dioxide gas.
Yes, sir.
Also see in another test tube you have taken lime water. What is the formula of lime water?
Basically,
Sir,
so,
CaOH2.
Correct. Yeah, Chakrika.
so basically, vinegar plus baking soda and lime water plus baking soda gives us the same thing, right? Basically, it produces the bubbles.
Repeat that again.
So basically, adding vinegar. So basically, adding
Mhm.
vinegar to baking soda and adding lime water to baking soda is the same thing, right?
Basically adding vinegar to baking soda or adding baking soda to vinegar. That's what you were saying, right? So both are the same thing actually.
No, sir. I meant adding vinegar to baking soda and adding lime water to baking soda is the same thing, right?
No, both are different things actually here. Both are different thing. Vinegar is an acid here. Baking soda is the base here. Okay, now a neutralization reaction is happening here. See, inside this, what is happening? Acetic acid is found inside the vinegar, and baking soda, which is a base, that is sodium bicarbonate, it is reacting to form a salt and form carbon dioxide gas is also released in it in this process. You know, water will also be formed, but carbon dioxide gas is also released in this process. Okay, now. So the bubbles that are formed in the mixture, that is of
Okay, sir.
carbon dioxide gas. Okay, you have covered the test tube using a fork, and via a bent pipe, it is being immersed into another test tube that consists of lime water, that is also called as slaked lime. Right now, that is also called as slaked lime, that is CaOH2, calcium hydroxide. This is calcium hydroxide. Now notice down when carbon dioxide gas will be passing into it. Now the color of it will start to change. The color will turn milky. Okay, now color will turn milky. So let's understand what is basically happening here. So as soon as carbon dioxide reacted with lime water, now calcium carbonate was formed and water was formed. And calcium carbonate is white in color. It is white in color. If you were to look at the color of marbles, look at the color of white marbles. So white marbles are basically calcium carbonate. Getting it, guys? Sundus, Vaika, and Chagrika, you all three of you
Yes,
getting it
sir.
or
We're
not?
getting it.
Right?
Yes,
Yes.
sir.
So calcium carbonate is white in color. So that is what has happened here. Any doubts in it, please do let me know. In chemistry, in laboratory, many times in order to check if in a given reaction, if you were to require to check whether carbon dioxide was formed in this reaction or not, you can check it using this experiment. What you can do, suppose you are doing a reaction between two components, A and B, and certain gases are evolving from the reaction. Now you don't know whether this is carbon dioxide gas, whether this is nitrogen dioxide, whether this is sulfur dioxide, you don't know that. Okay, now. So one of the possible things what you can do, you can basically collect this gas in a tube and you can make it to pass over the lime water, that is CaOH whole 2. And you will see that if the color of this calcium hydroxide changes to white, so thereby you can confirm that this is carbon dioxide gas. The gas evolved in the reaction between A and B was carbon dioxide. Is that clear? Is that clear to everyone?
Yes, sir.
Got
Yes,
it
sir.
now? Okay.
Yes, sir.
Last thing we need to study about is the process of crystallization. Okay, now. So what is the process of crystallization? Do you guys recall we discussed this in the previous class? I mean, when we were doing this chapter.
Yes, sir.
What is this?
So like crystallization is the process of cooling a hot solution of a substance to obtain crystals.
Correct, correct. So first of all, we will be now first before cooling, we have to first heat it, right? Now, for example,
So
understand this one. So you
in
be
at
yeah,
home,
Chakrika. Chakrika, will you please repeat again?
I'm just saying that we can also do it at home.
We can do it at home also, huh? You can obtain crystals of sugar also using the same
All
method.
salt.
Also salt also, very good. Right now. So basically crystallization, no, it is defined as the process in which a chemical is converted from its liquid state to a solid crystalline state. So the steps are as follows. So the steps goes by like this. First of all, you will take a solution,
Adya.
copper sulfate solution you have taken over the china dish, and notice that you are not directly heating it.
I'm not doing the same thing.
Yes.
Nothing, sir.
Okay. So we are not directly heating it. Okay, no. So you have placed a iron mesh here, that is a wire gauge, and the water is being boiled over here, and above the boiling water, the copper sulfate is also boiling here. Now you have removed the source of heat. Basically, it is being allowed to cool down. So after some time, what will happen? The water will start to evaporate. It will keep on evaporating, and then you will be left with the crystals of copper sulfate. Getting it? What is happening? Yes. Is that clear to everyone?
Yes,
So
sir.
Yes,
this
sir.
is the process with the help of which you can obtain crystals of a pure substance from its solution, right? So we had the example of this one where you can obtain the crystals of copper sulfate by boiling the copper sulfate solution. Okay, now, and we can also obtain crystals of like sugar, salt, etc. Okay. Now here basically what is happening now? The atoms, you guys understand about atoms, right? You guys understand about
Yes.
atoms.
Yes.
Okay. Also now, if you were to look at the size of the sugar cubes, they are in perfect shapes like this. Huh? If you were to look at the shape of the crystal of the sugar cubes, did we made that manually? Is it cut manually in this perfect shape in the industries? You guys getting my question? Yeah, Sundar, Swaika, and Chagrika. You guys getting my question or not?
So can you just repeat again?
My question is that if you were to look at the sugar crystals and the shape of them are perfect cube size, right now they are in the shape of cube. Okay, my question is that do we cut that manually? Is it manually cut or by the help of machines? Is it cut in the shape? The answer is
Sir, it can be manually cut.
no. Actually, it is not manually cut. It is not manually cut.
So, but
See
it's a
first.
crystal that is.
See,
Sir,
basic.
are you talking about a crystal that is made up of copper sulfate solution?
I'm talking about copper sulfate solution also. Right now, I'm talking about the sugar crystals. So see, if you were to look at the shape here, these are not neither manually cut, neither with the help of the machines. See, the thing is that if you were to look at the structure here, structure of the sugar cubes, so you will see that the atoms found in it are organized in a very defined state. They are very well organized. The arrangement of the atoms inside it is such that it gives it a 3D shape. Okay, now the atoms inside this is in such a manner organized to each other that it gives it a solid 3D shape. Getting it or not?
Yes, certainly.
Right. So that is the thing. The atoms inside it are organized. They are highly organized, right? Which gives it a 3D shape. So this is the thing basically which is happening. Okay. So where do we use crystallization? Wherever you would be having an impure mixture. If you have an impure mixture and you want to obtain a pure substance from it, so there you will be using the process of crystallization. Okay, now. So that is the thing. Wherever you want to obtain pure crystals from an impure substance, so it is done. Okay. Also, have you guys heard about alum? ALUM. Have you guys heard about
Yes, sir.
ALUM?
Yes, sir.
Heard about it? So
Yes, sir.
crystals of alum are also obtained in the same manner. Okay, no? That is also obtained in the same manner. Why the process of crystallization, right? So in there will be an impure. There is an impure alum, but that is not fit to be used. So in order to extract pure alum from it, now what is basically done? The impure alum is basically put into water. Right now, it is dissolved into water, and then it is heated. It is first heated just like the copper sulfate solution is being heated here, and after some time when it cools down, you will be left with pure alum. Okay, now hope it is clear. If there's any question or doubt in it, please do let me know.
No, sir.
Okay, now.
Sir,
Yes, on this. And from the chapter, if there's any other doubts, please do let me know. Apart from this topic.
No, sir.
No? Okay. So in the next class, we'll be taking up some questions from this chapter. All right.
Okay, sir.
okay, sir.
No? Also, you guys know, like in caves, also you might have seen crystals of precious metals. Huh? So in caves also they are formed in a different manner. There are various ways in which crystallization can take place, but the important minerals, important precious metals, for example, you have stalagmites. These are also found in the caves. So those are also example of crystals. Okay, no. Do one thing. Do search about stalagmite after the class. Okay, no.
Sir, what?
Let me
What
write
is
it
it now?
Again, sir.
here. Stalagmite. These are found in the caves. They are also they are also kind of crystals. Right now, actually they are made up of calcium carbonates, and they are also a type of crystals. Okay, no. So do study about that as well. You have like gemstones also. Gemstone crystals are also there. You guys understand about gemstone crystals or not? Gemstone. Let me write it.
So we also
Gemstone. Yes.
about that.
Different. This one, that is stalagmite. Chakrika, will you please repeat that again? What you were saying?
So we also have to research about gemstones.
No, gemstones are basically what? Like diamond is a gemstone. Ruby is a gemstone. Sapphire, right?
You're right.
Sapphire, ruby, diamond, all these are examples of gemstones. So they are also in crystalline state. They are also crystals. Getting it now? So that's why you will see, like, if you were to look at the shape of the diamond, look at the internal structure of the diamonds, they are organized in a they are very highly organized. Okay, now? So that is one characteristic about all the crystals. They are very high, they are highly organized atoms. Okay, so that's it for today. In the next class, we'll be taking up some question